Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Hello. We'll continue with Chapter 1, Stoichiometric Relationships. We study the mole concept. Fundamental components of matter are atoms, molecules, and ions. First, we study atoms. The mass of an atom is very small, and in practice, we are interested in the relationship between the atoms of the elements that interact in chemical reactions. This is why the relative atomic mass was defined. So, the relative atomic mass AR was defined. AR is equal the mass of one atom of the element divided with 1/12 of the mass of carbon atom 12. Relative atomic mass is used to compare masses of atoms. The prices of AR are given. You must understand what the means of the value of AR of atom. Then we have molecules. Molecules described by formulas shown all the atoms present in a molecule. We must understand the formula of a molecule. Example. Molecular formula for sulfuric acid is hydrogen 2, sulfur, oxygen 4. This means that the sulfuric acid molecule consists of two atoms of hydrogen, one atom of sulfur, and 4 atoms of oxygen. Now we study how we calculate the relative molecular mass. So we have calculation of relative molecular mass or relative formula mass known as MR. MR is equal with the sum of AR values of all atoms in molecule. Let's see examples. How we calculate MR. 1. For sulfuric acid, with formula hydrogen 2 sulfur 1 oxygen 4. So MR is equal AR of hydrogen times 2, the number of atoms of hydrogen in the molecule, plus AR sulfur times 1 plus AR oxygen times 4. So it's very important to understand the meaning of formula of sulfuric acid. And we replace the values of given AR, so we have and the result is 98.09. 2. Calcium hydroxide. With the same way, we have MR is equal AR of calcium times 1 plus AR of oxygen times 2 plus AR hydrogen plus 2. We replace the value of AR, so we have and the result is 74.10. 3. For the potassium, magnesium, chloride, exhydrate, or carnallite. With formula is anhydrate salt we find in nature. So we have Mr is equal AR of potassium times 1 plus AR chloride times 3 plus AR magnesium times 1 plus 6 times Mr of water. AR hydrogen times 2 and AR oxygen times 1. We replace the value of AR, the given AR, not forget, and so we have and the result is 277.88. The next important for the calculations in chemical problems is the molar mass. Molar mass is the mass of 1 mole of a substance. So we have 1. For sulfuric acid, we find Mr equal 98.09, so the molar mass is 98.09 grams mol minus 1. Also, for calcium hydroxide, we find Mr so the molar mass is equal with the value of Mr in grammar mol minus 1. The same for carnallite. We find Mr so we have the molar mass of carnallite. It's very important for chemistry problems to know to find Mr. Also, we have molar volume mole of a gas. We know that a gas has a specific mass and volume the volume of the container it is in. One important law for gases is Avogadro laws. According to Avogadro's law, we have equal volumes of all gases when measured at the same temperature. And pressure contain an equal number of molecules. The Avogadro's laws is very important for chemistry, for the gases. So we have what is molar volume. Molar volume, we can say volume mole of a gas is the volume occupied by 1 mole of any gas. Is also important as molar mass. According to Avogadro's law, 1 mole of gas contains L molecules. L is Avogadro constant. Remember, 6.02 times 10 in 23. So, all the gases will have the same molar volume. Of course, at given conditions of pressure and temperature. So we have molar volume is constant. In given pressure and temperature. What's the value of V mole, molar volume, depends of the volume of pressure and temperature. Important conditions of pressure and temperature is STP. STP is standard temperature and pressure. Pressure is equal 100 kilopascal and temperature is equal with 0 Celsius degrees E or 273.15 degrees Kelvin. So we find that in condition STP, 1 mole of a gas has volume equal 22.7 dm to the cube. .7 dm to the cube mole -1 is the value of molar volume at STP. It's very important to know it. Now we study the relationship between numbers of mole, mass, and number of mole. This is very important for the calculation in chemical problems. A. Conversions between numbers of molecules and numbers of mole. So we have from the number of particles if we divide by Avogadro constant L, we'll calculate the number of mole. And from the number of mole, if we multiply by Avogadro constant L, we'll find the number of particles. Or we can use the relationship n, small n, number of mole, is equal with number of particles divided with L. This is if we want to have a conversion from numbers of particles to number of mole. And the relationship number of particles is equal number of mole times constant Avogadro constant. This is for conversion from numbers of mole to the numbers of particles. Let's have an example. How to succeed the conversion. How many molecules of ammonia are present in 2.50 mole of ammonia? We can succeed the conversion using three ways. You choose the way is more comfortable for you. First way. One mole of ammonia has L equal 6.02 times 10 in 23 molecules. 20.50 mole ammonia has N molecules. So we have the relationship and the number of molecules is equal and we find the result. 15.05 times 10 in 23 molecules. This is the first way. Second way. Which I prefer. We use the relationship number of moles is equal with number of particles divided with Avogadro constant. We replace the values, so we have the number of molecules and we find the same result. The third way, we can do it straight. We have 2.50 mol or 2.50 times the Avogadro constant and we have quickly the number of molecules. You can use one of the three ways. How we can now succeed the conversion? Between mass and number of mole. In this conversion, we need the value of MR. So we have, if the number of mole multiply by molar mass will find the mass we need. And if we know the mass, from the mass, if we divide by molar mass, we'll find the number of moles. Or, for the conversion, we use the relationship. Number of mole is equal with mass divided with molar mass. So, we have the conversion from the mass we find the number of mole, or mass is equal with number of mole times molar mass. So we succeed the conversion from number of mole to mass. Let's see some examples how we succeed this conversion. Example. What is the mass of 4 mole carbon dioxide? We're interested for the mass of carbon dioxide. So we need the value of MR. For carbon dioxide, MR is equal AR of carbon which is given times 1 plus AR of oxygen times 2, and the value is 44.01. So we know the molar mass. First way, which I prefer, we use the relationship number of mole is equal with mass and divide with molar mass, and we replace the value. 4 mole is equal mass with the molar mass. So M is equal 4 times 44.01, and mass is equal 176.04 grams. Second way, we know that 1 mole of carbon dioxide has mass equal with the value of AR grams. So 4 mole of carbon dioxide has mass m grams. So we have the relationship and we find the mass multiplying 44.01 times 4, and we have the same value, of course. And third way, more quickly, we have 4 mole of carbon dioxide, or 4 we multiply with molar mass, equal with the same value. And the third conversion is the conversion between numbers of mole and volume, of course, for gases. Let's see the way we succeeded. If we know the number of mole, this number will multiply by molar volume, and we find the volume of the gas. If we know the volume of a gas and this volume divide by molar volume, we'll find the number of mole. Or we can succeed the conversion if we use the relationship. Number of mole is equal with volume of a gas divided with molar volume. This is a conversion from volume of gas to find the number of mole. Or volume is equal with number of mole times molar volume if we want to have the conversion from number of mole to volume of gas. Let's see examples. First example. Calculate the volume occupied by 2.50 mole of hydrogen at STP, standard temperature and pressure. We can have the solution. First way, I prefer it. We use the relationship volume is equal with number of mole times molar volume. So we replace the values and we have volume is 2.50 mole times 22.7 dm to the cube mole minus 1. So we have the value 56.75 dm to the cube. Second way, more quickly, 2.50 mole or 2.50 times the value of molar volume, 22.7 dm to the cube mole minus 1 equal 56.75 dm to the cube. And the third way, we know that 1 mole hydrogen has volume 22.7 dm to the cube at STP. 2.50 mole hydrogen, which the volume which occupied. So we have the relationship which give us the value of the volume. So volume is equal the same value. Second example. Calculate the mass of 90.8 dm to the cube carbon dioxide at STP. We have the solution. We read distinct about mass of carbon dioxide, so we need MR. For carbon dioxide, MR is equal AR of carbon times 1 plus AR of oxygen plus 2. And we have MR for carbon dioxide. So then the molar mass. First, we find the number of moles as we know the value of volume. So we use the relationship N equal V divided with mole. We replace and we have. We replace the number, the value of volume and the number of molar volume at STP. So we find that we have 4 mole for carbon dioxide. Then we find from numbers of mole the mass of carbon dioxide. So we use the relationship N equal mass divided with molar mass. So we have the result. Mass is 4 mole times 42.01 gram mole minus 1. So the mass is equal 176.04 grams. So we succeed the conversion. Finally, we see the fundamental knowledge, which is one mole of gas first has mass equal with MR grams. 1 mole of gas contains L equal 6.2 times 10 in 23 molecules. And occupied volume of 22.7 dm to the cube at STP. And the important relationships are: the number of mole is equal with number of particles divided with the Avogadro constant. The number of mole is equal with a mass divided with molar mass, and the number of mole is equal with the value of volume divided with molar volume. This is only for gases. This is the three important relationships to succeed the conversion between the numbers of mole, numbers of molecule, mass, and volume of gas. Thanks for listening, and more IB chemistry videos to come. If you like the video, and you can support me on Patreon. Thank you.